Hello everyone, I am Kashish Ahuja from IIPS DAVV pursuing Integrated MTech IT currently in 6th semester. This video is a part of my Advanced Java assignment, and in this video we will learn about thread priorities, daemon thread and life cycle of a thread. So let's begin. Index, thread, life cycle of thread priorities, setter and getter methods, constants of thread class, daemon thread, methods for daemon thread. Thread. Thread is a lightweight subprocess. It's the smallest unit of processing. It is a separate path of execution. Threads are independent. If there occurs exception in one thread, it does not affect the other threads. It uses a shared memory area. As shown in the figure, a thread is executed inside the process. There is context switching between the threads, and there can be multiple processes inside the OS. One process can also have multiple threads, but at a time only one thread is executed. Life cycle of a thread. A thread goes through various stages in its life cycle. For example, a thread is born, started, runs, and then dies. Following diagram shows complete life cycle of a thread. The stages shown in the previous diagram are discussed in this slide. New. A new thread begins its life cycle in the new state. It remains in the state until the programmer starts the thread. It also referred to as born thread. Runnable. After a newly born thread is started, the thread becomes runnable. A thread in this state is considered to be executing its task. Waiting. Sometimes a thread transitions to the waiting state while the thread waits for another thread to perform a task. A thread transitions back to the runnable state only when another thread signals the waiting thread to continue executing. Timed waiting. A runnable thread can enter the timed waiting state for a specified interval of time. A thread in this state transitions back to the runnable state when the time interval expires or when the event it is waiting for occurs. Terminated. Dead. A runnable thread enters the terminated state when it completes all its tasks or otherwise terminated. Now let's look at a program for thread state. Here, the demo class is implementing the runnable interface. Then there is a try catch block in which we can see that the thread T2 is moved to a state of timed waiting. Then there is again a try catch block. This is the class that implements the runnable state, and this is the main method of the program from where the execution of the program starts. Now here we are creating an object of the thread state class. Here the thread T1 is spawned, so currently it is in the new state. Now we are invoking the start method on thread T1. Here the thread T1 has moved to the runnable state. In the run method, we can see that the thread T2 is currently created, and so here it is in the new state. Thread T2 is moved to the runnable state after calling the start method. Here again, the thread T1 is moved to the timed waiting state. Here, waiting for thread T2 to complete its execution. Now let us run this program and look at the output. In the output, we can see that at first the state of the thread was new. Then after starting the thread, its state become runnable. The state of thread 2 was new, and after invoking the start method, its state becomes runnable. When we invoke the join method, the thread 2 state is timed waiting, or invoking the sleep method also puts the thread into the timed waiting state. After completing the execution, the state of the thread T2 is terminated. Explanation. Whenever we spawn a new thread, the thread attains the new state. When the method start is invoked on a thread, the thread scheduler moves the thread to the runnable state. Now, whenever the join method is invoked on any thread instance, the current thread executing that statement has to wait for this thread to finish its execution, that is, move that thread to the terminated state. Therefore, before the final print statement is printed on the console, the program invokes the method join on thread 2, making the thread 1 to wait while the thread 2 finishes its execution, and thus the thread 2 gets to terminate or death state. Thread T1 goes to the waiting state because it is waiting for the thread T2 to finish its execution, and it has invoked the method join on thread T2. Thread priority. Each thread has a priority. Priorities are represented by a number between 1 and 10. In most cases, the thread scheduler schedules the thread according to their priority, known as primitive scheduling. Not only JVM, but a Java programmer can also assign the priorities of a thread explicitly in Java program. Setter and getter methods of thread priority. Let's discuss the setter and getter methods of thread priority. Public, final, and get priority. The get priority method is used to return the priority of the given thread. Public, final, void, set priority, int new priority. The set priority method updates or assigns the priority of the thread to the new priority. The method throws illegal argument exception if the value new priority goes out of the range, which is 1 minimum or 10 maximum. Constants of thread class. There are three constants defined in thread class, that are minimum priority, normal priority, and maximum priority. Minimum priority is defined by min priority, and it has the minimum value of priority, that is 1. Normal priority is defined by norm priority, and it has the default value or default priority of a thread, that is 5. Maximum priority is defined by max priority, and it has the value 10, which is the maximum priority a thread can attain. Let us now look at a program for thread priorities. In this program, first we are importing the required classes. Then, whenever we are calling the start method, it invokes the run method. Here, this is the main method for the program. Here, thread objects are created with the help of thread priority class. Now, we didn't mention any priority for the thread, therefore the normal priority, which is by default, is 5. Now, we are printing the priority of all the three threads. Here, we are setting the priority of the first thread to 6, setting the priority of the second thread to 3, and setting the priority of third thread to 9. Again, we are displaying all the priority of all the three threads. Now the main thread, the current thread executing is the main thread. So we are displaying the name of the main thread and then the priority of the main thread. Here we are setting the priority of current thread, which is main thread, to 10 maximum priority, and then we are printing the main thread priority by using the method get priority. Let's now see the output of the program. As we can see, at first the priority of all the three threads was 5. Then after setting the priorities, the priority of first thread is 6, second is third 3, and the third thread is 9. Execution of the main thread was with the priority of 5, which is default, and after setting it to 10, it was executed with the priority of 10. Daemon thread. Daemon thread in Java is a service provider thread that provides service to the user thread for background supporting tasks. It has no role in life than to provide service to the user thread. Its life depends on the mercy of user threads. That is, when all the threads dies, JVM also terminates this thread automatically. It is a low priority thread. There are many daemon threads running automatically in for example, GC, finalizer, etc. Why does the JVM terminates the daemon thread if there are no user threads? The sole purpose of daemon thread is that it provides service to the user thread for background supporting tasks. If there is no user thread, there is no reason for the JVM to keep running the daemon thread. That is why JVM terminates the daemon thread if there is no user thread. Methods for daemon thread. Public void setDaemon. SetDaemon method is used to mark the current thread as a daemon thread or user thread. Public boolean isDaemon. The isDaemon method is used to check that if whether a current thread is daemon or not. Now let us look at a program for daemon thread. In this program, first we are extending the thread class. Now here in the run method we are checking that whether or not is a thread daemon. We are doing this by the method isDaemon. If the thread is daemon, we are printing daemon thread work, and if the thread is not daemon, we are printing user thread work. This is the main method of the program. We are creating thread objects with the help of daemon thread class. Now, for the first thread, we are setting it as a daemon thread by the method setDaemon, and the rest two threads are still user threads. Then we are starting all the three threads. Let us now see the output of the program. As we set the first thread as daemon, the first thread is printing daemon thread work, and the rest two threads were still user threads, so they are printing user thread work. Thank you.